So in this slide, we'll talk about cannabinoid and terpene testing. Kind of similar to the pesticides. These are organic molecules that are best tested by chemistry, and things like LCMS are common ways of doing the detection, or GCMS. Right? The chromatography, mass spectrometry, you separate the molecules and then you identify them better. So what are these molecules? Well, these are the ones that aren't so much about safety, but really about efficacy. Is the consumer getting what they're supposed to get? But there's some safety, right? Since THC is psychoactive, getting the wrong amount of it could cause health problems because you wouldn't be able to control your dose, right? The terpenes really, there are a lot of claims made about terpenes, and so they're things that can be tested for, but it's not a requirement that terpenes are tested for. They are more of an efficacy product claim kind of test that can be done. So where does this THC come from? Well, it's interesting to know that in the flowers of cannabis, they make, by themselves in their own cells, something called THCA, which is sort of the acid version of THC. And they also make CBDA. Okay? And it turns out that those don't actually become the active versions that do things in the body until they become the non-acid form. Right? So in the flowers, you saw those pictures in earlier slides. The flowers are really these funny crammed shaped things, but they have these little structures on them that are called trichomes. And lots of plants have trichomes. And they're places that secrete substances. And so you've probably, if you've ever held a tomato plant and once you touch it, it kind of releases this smell, that's coming off of the trichomes, really similarly to the way that cannabis trichomes So these little trichomes are where the THCA and CBDA are made, and they're secreted a little bit. But then when you go through the curing process, and that has heat a little bit, there's drying, that is where, and then some amount of light and dark, right? That affects these acid forms going to the non-acid forms. So you still have the curing doesn't really change this except that it gets it dried, right? So less water, right? You still have the trichomes, but instead of so much THCA and CBDA, you have the THC and the CBD kind of as the secreted substances. They're already out there, but they've converted from the A form to the non-acid form. Okay, and so so that's one thing to know. And you can test, when you do the test, you end up detecting both THCA and THC and CBDA and CBD, and there are other cannabinoids as well. We won't talk about them all right now. Okay, so that's just good to know. And there's one other really important thing to pay attention to in the testing of this, is that CBD can convert to THC with acid conditions. And CBDA can convert to THCA with acid conditions. Now, why would that matter? Well, remember, THC is the psychoactive component, CBD is the non-psychoactive major cannabinoid. And so if after you have your product, during this sampling and testing process, you add acids, you could get a higher THC content than was really in the buds. So you have to be careful during sample preparation and extraction of these molecules out of the homogenized material into the solvent used for the test, right? You want to make sure that solvent is non-acidic, and it turns out that heat affects this as well. So you want to have that solvent be non-acidic and the extraction in the cool, not a hot environment, okay? Or else, think about it. So if you took this and homogenized it and you had all your little pieces, remember, and it's got our THC and it's got our C, and maybe we've got twice as much CBDs as THCs in every piece because it was a low THC relative to CBD piece of plant, right? What if our solvent had some acid? Well, then you'd end up with those little pieces and eventually the stuff dissolving off. Some of these C's might turn to THCs, right? And so then you'd end up with only a few C's and lots of T's when you went off to analyze. But if you had a solvent with low acid, right, and you took out your sample, well, you might have many more C's and just a few T's, right? This sample looks like it's very high in THC. This sample looks like it's much lower in THC, but really they came from the same plant. It was just that the extraction had more acid in it or the extraction had less acid in it, right? So when you do the sample testing, super important to make sure you have non-acidic conditions and cool conditions when you are making your extraction into the solvent that then, remember, so a little bit more about the extraction, just so you can think about how that goes for both cannabinoids